And I'd now like to introduce to the stage Aviv Revach. And Aviv is a FinOps Foundation governing board member from Adaptive 6.
Hi, everyone. I hope you're not too tired after lunch and everything, so I hope I'll keep you, a little bit more energetic. So let's get started. So pleasure meeting you. I'm Aviv. I'm the CEO of Adaptive 6 in the space of cloud cost governance and optimization. As Dean mentioned, I'm also on the governing board in the FinOps Foundation. And today we're here to talk about shadow waste, eliminating hidden inefficiencies in both cloud and code. So let's just get started. So talking about shadow waste, what is shadow waste? So we're talking about these hidden inefficiencies that typically evade the standard tooling. So not the type of inefficiencies you would see within your Azure Advisor or GCP recommender, right? And not the type of things you would see within, the common FinOps providers. So we're talking about several examples like complex service misconfigurations, right? Or these hidden features within the cloud that maybe most engineers are really unaware of, right? And all the way to applicative inefficiencies. Many times we all think about the infrastructure, but what's happening inside the workload? You have a lot of inefficiencies over there as well. And lastly here, like the AI and machine learning workloads. Obviously, this is booming. A lot of engineers are unaware necessarily of the right ways to actually optimize. So a lot of the shadow waste also lives over there. What's interesting is that many times these types of shadow waste are harder to detect, but then very easy to fix, right? Than common right-sizing opportunities and these type of aspects. So actually, while harder to find, many times this could actually be low-hanging fruits that are worth the time, right? So worth the time in detecting and worth the time in actually remediating those. The other bit I would like to stress is that, many times, even if you are aware of many of these inefficiencies within the cloud and shadow waste and all of that, but many times we see folks that just rush off and try to fix stuff on the cloud. But that doesn't really make sense in an infrastructure as code world, right? So if your organization is using Terraform or CloudFormation or Ansible or whatever it is, typically if you go and try to fix these types of waste within the cloud, the code would run later on and would just override the changes. Doesn't make sense, right? So this is really where the code wins, and the way to do these types of fixes is really to focus on the code, right? To basically codify those fixes, and not just present engineers with a way to fix them in the cloud, but ways to fix it within the code. So actually preparing to them, if possible, pull requests, right? These pull requests are basically the code fixes that with one click, they could potentially place it within their code base, within their GitHub, and so on. So these type of problems wouldn't reappear over and over again, right? And then obviously it would go through the standard testing that developers typically do, and it's auditable, and so on. So I'd like to move forward with some, four real-world examples of shadow waste and the ways to really remediate those both in cloud and code. So the first example is within the applicative layer, right? So for instance, if some of your workloads are using Python programming language before version 3.13, that could actually be up to 20% less efficient and more costly than Python 3.13. Now, this is a big one most folks don't typically think about when they think about waste. So this is an hidden inefficiency. And this is not because of end of life of prior versions of Python, but this is because specifically in version 3.13 of Python, they made a major change to the engine that made it far more efficient, right? So they improved their interpreter, they improved their concurrency, and so on. So really, if you have workloads, whether it's within VMs or whether it's within serverless functions, like Lambdas and others, that are using something like, Python 3.10 right here, and then really you should be looking at trying to upgrade those into 3.13, right, in this scenario. And then the code fix itself for doing some of these things is very simple. What we see right here, this is basically Terraform code, and you could basically see it's a simple change of the code, like simple one-line change from 3.10 to 3.13. Obviously, it still needs to go through testing and the software development lifecycle and all of that. But if you make that part accessible to the developer, it would make their lives so much easier, right? So this is the first example. The second example of shadow waste is architectural inefficiencies, right? So this is just one example within that category. In this case, networking architecture, right? So we see that many times developers, engineers, by default, like let's say we're talking about like this example is AWS, same goes for other clouds. But within AWS, you could set up a network either by using transit gateways or VPC peering, right? And which one do you choose? And we see that engineers by default many times use transit gateways, right? Now that might actually be an overkill for your setup, because if you only have a small number of VPCs, you don't really need the transit gateway in that regard, and maybe you're also not really using the premium features the transit gateways really provide. So in this case, what we are seeing here on the right, this is the code change, right? So in this case, this is even more complex code change. We're seeing we're seeing like this is basically the VPC peering, and on the bottom part, you actually see the transit gateways. So the developer would have to really work hard in order to make those changes. But if you could go ahead and actually help them with it by creating those pull requests, finding the ways, and today with AI, there is a lot of feasibility of doing these things, you could really accelerate those fixes. Otherwise, folks might come in and say, okay, this is too big, I'm not looking at it right now, and just keep postponing it, as we all know typically sometimes happens. The third example is within AI and machine learning, right? So many of the cloud providers, like GCP in this example, but also others, they have what they call provision throughput. So you can actually commit to the cloud for a certain throughput, and you get a discount. If you don't commit, you're losing money. If you overcommit, you're losing money. So the question is, how much of a commitment you need to do? So over here, we are analyzing the workload, the LLM, and we see that all you need is just 2 units of throughput instead of 6, right? And just by making that simple change, you could basically have high savings by doing that. But of course, you need to also bear in mind what are the necessities of your workload. What actually do they need in terms of provision throughput? And the fourth and last example here is also within AI and machine learning. So essentially, we see that many times developers, they also opt in to be using the latest and greatest models. And that, in reality, like we are all thinking about that, but many times it's not really needed. So if the workload, for instance, the LLM is actually doing some work of, classification, right? Or summaries of text and so on, you probably don't really need GPT-5 in this example. You could probably settle for GPT-5 Mini that you see over there in the bottom. And you could basically get the same or very similar level of quality, and you could decrease the cost by 80%. In this case, up to 90% in other cases. So this is really important. And by the way to detect these type of things, for instance, you should be looking at cases that you have a lot of tokens, a lot of high input, basically to the model, and you see that the output is very small. This typically would signal that this workload might be doing some summary work or some classification and so on. So these are the small hints you should be looking at to try and find these types of shadow waste. So really what I'd like to highlight is the fact that beyond finding these shadow waste, you should really be looking at fixing it at the source, whether it's Terraform, CloudFormation, whatever the organization really uses, and then really integrating within the engineer's pipelines, right? So open up a Jira ticket or a ServiceNow ticket, create an automated pull request for the engineers so they could actually, with one click, just deploy it and move on, right? Because at the end of the day, we all know engineers are super busy, they have higher priorities, but this is really the way to make it very, very seamless and very easy for them to actually move forward. And the last bit right here is that it's not just about finding the waste and shadow waste and then accelerating it, but how could we actually prevent it from the get-go, right? So just like I come from cybersecurity, our entire leadership in the company, we come from cybersecurity. And within cybersecurity, there is a lot of similarities. Like you could actually run, security checks on code before it goes live. So why not do the same for FinOps, right? So over here, by placing these cost guardrails, by shifting left, by scanning code before it goes live, you could actually guarantee that a lot of this waste doesn't even come to the cloud to begin with, right? So in this example right here, this is an Azure example, why would you use premium app service plans within non-production? For non-production, you probably could settle for the non-premium ones, right? You could probably settle for the standard ones, right? So this is another good example. So to sum it up, really focus on shadow waste. It basically hides beyond just the common dashboards, so you should be looking for it. Fix issues at the code, not just the cloud, because changes are gonna, basically be made. It's gonna get overwritten. Embed remediation into the engineering workflows, and try to shift left as much as possible. So I'd like to say thank you for, for everybody who joined the conversation. If you'd like to continue, I'd love that either today or you could scan the QR code to continue chatting about cost governance and optimization. And happy to share more ideas and findings of the things we really see out there in the wild. So thank you very much.
Hey everyone, producer Andrew here. Thank you so much for watching and for your support. For more FinOps content, go check out our YouTube channel. Like, subscribe, and leave comments and questions for all of our wonderful speakers. We appreciate your support.